Check, am I audible? Please let me know first. Hello, am I audible
Yes,
to you?
sir. Audible, sir.
Okay, good.
Yes, sir.
Yes, sir.
Check, am I audible? Hello,
Yes,
am I
sir.
audible? Okay. Okay, so today we are starting strength and endurance problems. कुछ प्रॉब्लम है क्या? Something wrong? Can you check, please?
No, sir.
Actually, आपका इको आ रहा है मुझे. मिनट. Just a minute. Shall we start now? Check, please.
Yes,
Not
sir.
check.
Yes, sir.
Okay. Okay. Just wait. Okay. So they have asked one question in GATE 2021. The question is that a jet aircraft has the following specifications. Wing loading is given here, like 1800 Newton per meter square. Then wing area is given 30 meters square. Drag polar of this aircraft is given. CL max value is given to you. You are saying take the density of air at sea level is 1.225 kg per meter cube. Now the speed at which the aircraft achieves maximum endurance in a steady and level flight. Please underline this. At sea level is in meter per second, round out to 2 decimal places. So can you solve this problem? Yes. How to approach? First of all, which aircraft is this? Jet engine aircraft, or is it piston based, or you can say propeller based aircraft? It is simply written here. It's a jet aircraft, right? So generally in range and endurance, if suppose if you are dealing with this jet engine aircraft, then we are having two formula. One is endurance, another one is what? Range formula, right? Similarly, we are having for this piston based, or you can say propeller based aircraft, right? So what are the formulas? Anyone for this jet engine? Yes. Anyone? Okay, please comment in chat box. If you know, please comment in chat box. Or just please unmute and answer. What is the formula? Narsimha, are you there? Parsha? Arya? What is the formula? Capital R you shall do. What is the formula? Kushi, are you there?
Capital for jet engine aircraft, capital R is equals to 1 upon TSFC, CL
1
power
upon? Sorry,
1
come
by
again.
TSFC, CP.
Okay.
CL power 1 by 2 by CD, under root
Right.
2 by rho infinity s, W naught raised to 1 by 2 minus W1 raised to 1 by 2. और endurance के लिए 1 upon CT L by D ln W naught by W1.
Can you come again with this range formula? What is capital R?
R is equals to 1 upon CT CL power 1 by 2 by CD under root 2 by rho infinity S. 2 divided by rho infinity S W naught into W naught raised to 1 by 2 minus W1 raised to 1 by 2. बस खत्म.
Are you sure?
Yes, sir.
Any other student?
Sir, 2 by TSFC.
Sorry.
2 by TSFC.
Okay, tell me what is the formula?
2 by TSFC into root of 2 by rho s into CL raised to 1 by 2 by CD into root of W1 minus root of W2.
Okay, now which one is correct? Kushi, your formula is correct or what's your name?
Yes, sir. Sir, 2.
Ram.
Ram. Yeah, so which one is correct?
सर राम का फॉर्मूला
Yes,
सही
sir.
है
2 आएगा.
So please take care. Okay, please revise properly. If you forgot the formula, then how can you answer this question? Okay, so write down Range formula capital R is equal to, write down capital R is equal to what is the formula? 2 upon CT into what is next? Root of
CL half
root of
2 upon rho infinity S.
rho infinity into S into
Yes.
how much? CL raised power
CL 1 by 2 upon CD.
upon CD, right? Into how much? Yes,
Root W naught minus root W1.
root W naught minus root of W1, right? That's your Range formula for this jet engine aircraft. For jet engine, power plant, or you can say aircraft. Now, so what is given in this question? What is given? Let's write down. Wing loading is given, so generally we define the wing loading small w is equal to capital W upon S, which is given here. How much? 1800 Newton per meter square, or you can say it's a Pascal. Then wing area is given, capital W is equal to 30 meters square. Then drag polar of this aircraft is given, CD is equal to how much? 0.02 plus 0.04 CL square, comma, CL max value is also given here. CL max is given 1.6, comma, take density of air at sea level. So density given here, rho is equal to 1.225 kg per meter cube, right? Check. You are saying the speed at which the aircraft achieves the maximum endurance. So they are asking what is the speed of this aircraft for maximum endurance. Now, how to approach this question? Look, if you look at this range formula, if you keep all the parameters same, like what is the gross takeoff weight, right? What is the W1 here, or you can say WE, no issue at all. Then CL raised power 1 by 2 upon CD. This is nothing but you can say rho infinity into S, and this is nothing but 2 upon CD. If you keep all the parameters same, or if you look at this carefully, right? Then here you can write R is directly proportional to CL raised power 1 by 2 upon CD. Which condition is this? Is it minimum drag condition,
D by V.
minimum power condition, or minimum D by V condition? Which condition is this?
Minimum D by V.
Minimum D by V.
Minimum D by V condition, right? So you know that very well. If suppose if you want to maximize the range, right, of this jet engine aircraft, you must have, you can say, lower amount of the what is this CT here? Anyone? What
TSF.
is this CT?
TSF.
Thrust
Yes, yes.
specific fuel consumption.
Specific fuel consumption.
What is
Yes,
this
sir.
rho infinity here? You can say this is nothing what you can say density. Capital S here is nothing what you can say it's a wing plane form area, right? So what you can write here, or what you can understand, if suppose if you are flying this aircraft at mean sea level, right? Or let's discuss R is something like this. Check. Agree? Then R is also. Then any other parameter? Yes. Then obviously this one is also there. So from here, what you can observe, if suppose if you want to maximize the range of this aircraft, we have to fly the aircraft at higher altitudes. Why? Because as the altitude increases, then you can see the density decreases. Are you agree?
Yes, sir.
Yes sir.
It means
सर
that what?
इसमें तो endurance का पूछा है ना?
Are they asking endurance or range? Okay. Okay, no issue. Let's discuss what about the range. Then we will deal with this endurance. No issue at all. Okay. So in this case, what happens? So is it endurance formula or range formula? I think this is range formula, right?
Yes, sir. Range
Yes
formula.
sir.
Yes, sir.
So
Range formula.
don't worry, we are going to discuss these all things. Okay. So what I want to convey, yes, please.
सर फोकस मोड ऑन कर दीजिए ना, वो स्क्रीन चली जाती है बार बार.
Okay, okay, just wait. Let me. Now, okay, please check.
Yes, sir.
Okay. So here, if suppose if we talk about the range of this jet engine aircraft, right? Then as the altitude increases, then the ambient density decreases. It means that what? This denominator value decreases, then the value of capital R increases. Okay, please remember, it's a final revision. And here, this is CT, right? Again, if the thrust specific fuel consumption decreases, then the range of the aircraft increases. Similarly, you can write for this capital S, or you can say wing loading also. So shall I ask you one question? You can answer that question in our official group. Okay. Okay. Which one is required? If suppose if we talk about, you can see the landing as well as the takeoff as well as the cruise flight. So which one is desirable? High wing loading or low wing loading during the cruise flight, or you can say during the steady state level flight? Which wing loading is required? High wing loading or low wing loading? You should have to answer in our official group. Okay.
Yes, sir.
And then what is required, or you can say what is desirable for, you can say the landing as well as the for the takeoff? High wing loading or low wing loading? Okay. Okay. Now here let's write down what is our range formula. Sorry, endurance formula. E is equal to, what is the formula? 1 upon, yes, what is the formula? Capital E is equal to 1 upon CT. Check. Hello. E is equal to 1 upon CT into CL upon CD, or you can say L by the ratio into ln of W naught upon W1, right? Check. 1 upon
Yes,
CT,
sir.
right, into how much? CL upon CD into, which is nothing but you can say ln of how much?
W naught by W naught.
W naught by W1. Okay. Now from here, as you can see, again, endurance is, you can delete something like this. Then again, is directly proportional to CL upon CD. And again, can write is directly proportional to ln of W naught upon W1. So how we can increase the endurance of this aircraft? If suppose the CT is low, then the E value will increase, right? If suppose anyhow, if you increase the L by D ratio, or you can say CL by CD ratio, or you can say aerodynamic efficiency, if suppose this value increases, then this value is also increases. Again, what is this W1 or W0 here? Either you can write W1 is nothing what you can say WE here. This is nothing what you can say the fuel of weight of the fuel plus you can say empty weight, or you can say it's a during the flight, generally we consider it as instantaneous weight. Okay. Now, so from here, what you can write? You can write here E tends to E max when L by D ratio becomes L by D max, right? So, which condition is this? This is nothing but we generally call it is the minimum drag condition. So, meaning what? If suppose if you want to maximize the endurance of this aircraft for a particular fuel tank for a particular amount of the fuel, then we should have to fly, or pilot should have to fly this aircraft under the minimum drag condition. So what is your minimum drag condition? Simply this CD naught is equal to CDI, right? Now from here you know very well the CDI is nothing but you can say CL square upon pi EAR, right? Now just calculate what is the value of CL with the help of this one. So can you calculate? Yes, we can. So we can write here the CD naught is nothing but, or simply you can write the CDI is nothing but you can say how much? KCL square, right? So this CD naught is nothing but you can say KCL square. Now from here, can you calculate what is the value of CL? Which is nothing but you can say root of CD naught upon K. Now, just simplify. What is the value of this CD naught here? Yes, please. Can you tell me? What is the value of CD naught? CD naught value here is given 0.02 and K value is given 0.04. CD naught is how much? 0.02. CDI or sorry, K value is 0.04. So how much you will get?
0.7071.
So you will get this value is how much? 1 by 2. Check please. Are you getting this one?
Yes, sir. Yes, sir.
Okay. So what is this CL? You can write this is nothing but you can say 1 upon root 2. Agree? Now, what is root 2? You can say this is nothing 1.414. Please verify.
Yes, sir.
Okay. So if you simplify it further, how much you will get? What is the value of CL? How much you are getting?
0.7073.
This value is 0.707, right? Once you get the value of CL, right? This value is corresponds to what? It corresponds to minimum drag condition, or you can say this value corresponds to minimum drag condition. Agree? Check. Now, once you get the value of CL and D, now it's very easy to calculate the speed of this aircraft. For example, let's consider this is the aircraft which is flying at certain altitude, having the forward speed B. So they are asking, what is this B for maximum endurance, right? Now, it is flying in steady state and level flight only. So you can write here, this is the weight, which is X vertically downward. Then this is our flight path. This is the lift. This is the thrust. And here, the drag. So the aircraft is flying in this condition, or you can say L is equal to W and T is equal to T, right? Now from here we can write L is equal to W. What is L? 1 by 2 half rho V square S into CL is equal to W. So calculate what is the value of V from here. You will get root of 2W divided by how much? Yes, rho S into CL. Yes, please. Clear or not? Now, we can calculate. In this question, the value of WYS is given, so you can write here the 2 into WYS. It is directly given in this question, divided by rho into CL. Now, it's a 2 into what is the value of WYS, or you can say wing loading, 1800 or 600?
1800.
1800, right? Divided by what is the density? They are considering 1.225. 1.225. Okay, into what is the lift coefficient we are getting?
0.707.
We are getting it 0.707. Now, just simplify and let me know what is the value of this speed. How much you are getting?
64.47234.
64.234.
47234.
Okay, please come again.
Sir,
60.
Sir, 64.47324. 47, sir.
This one?
324. Yes, sir.
Please verify
sir.
this value. Please verify. Hello? Please comment in chat box yes or no. Are you getting this one?
Yes, sir.
Yes, sir.
Okay. So the final value we are getting b equal to how many decimal points they are asking? Are they asking the nearest integer or up to the 2 decimal point or 3 decimal point? What they are asking?
2 decimal.
Up to 2 decimal point, right? So obviously we can neglect these three. We are getting 64.47 meter per second. That's your final value. Let's check whether this value is in the range or not. How much we are getting? 64.47. So the range is given here 64.30 to 64.60, right? Now, let's discuss another question. This question they have asked in GATE 2021. It's a MSQ type question. They are asking which of the following statement is or are true. Please consider this one. First one, service ceiling is higher than the absolute ceiling for a piston propeller aircraft. Is it true?
False.
See, doesn't matter which aircraft is this, right? The absolute ceiling is higher than what? The service ceiling. Agree? Check, please. Are you agree or not?
Yes, sir.
Your service ceiling is higher than, sorry, your absolute ceiling is higher than what? Service ceiling value, right? Check. Or even if you want to check the diagram, then it is something like this. Can you refer this one? This is absolute ceiling, service ceiling. Here rate of climb is given, right? And here this point is nothing but this altitude is nothing but you can say it's a absolute ceiling, and this is nothing but you can say it's a service ceiling here, right? Here this is what you can say h, which is nothing but you can say altitude. Here this is what you can say it's a ROC max, means rate of climb, right? So your absolute ceiling right? So your first option is incorrect. Now we talk about the second point here. They are saying for a given aircraft, okay, the stall speed increases with increase in altitude. I think we have discussed this question in last class, right? Now, what is our stalling speed? Look.
The minimum speed at which airplane can
Okay, if suppose
sustain
if you want,
cruise flight.
if you write this formula, V stall equal to root of 2W divided by rho s CL max, right? Clear? Now, what they're asking? They're asking for a given aircraft, the stall speed increases with increase in altitude. Just comment. Now, here, this density is the parameter which is associated with the altitude, right? Why? Because as the altitude increases, then your density decreases. So from here, if you want to write like V stall here is something like this. So as the altitude increases, this density value decreases, then your stalling speed increases, right? Check please.
Yes, sir.
Clear? So your option B is correct. Second one, everything else remaining the same, the tailwind increases the range of an aircraft. So even I have given one formula, right? Means how to calculate the range of the aircraft in wind, right? Or you can say in wind model, or you can say with zero wind model, right? So here you should have to remember, like during the takeoff and landing, right? During the takeoff and landing, your headwind is the favorable, right? Say yes or no.
Yes, sir.
Let's discuss one more time here. During the takeoff and landing, headwind is preferable, or you can say headwind is favorable. But during the cruise flight, or you can say during the steady state and level flight, what happens? Anyone? Your tailwind is the favorable. Reason is what? It increases the range of the aircraft, because the range of the aircraft is not the function of the airspeed, but the range of the aircraft is the function of the ground speed, right? Check please. Are you getting? Please go through the formula. Are you
Yes, sir.
getting this or not? Please refer notes properly. Please keep revising as much as you can. Clear? The range of the aircraft is depends upon, you can see the type of wind, whether it's a headwind or you can say whether it's a tailwind. Let me explain this one also here. Let's say this is the aircraft, right? Is it visible to you? Is it
Yes,
visible?
Yes, sir.
Okay. So let's say we can consider two cases here. One is tailwind, right? And this is nothing what you can say headwind here. Now, this is another diagram. So headwind conditions, you can see during the time of takeoff, it requires the shorter takeoff distance required, or you can say, if suppose if the aircraft is if aircraft encounters the headwind, then the takeoff distance will be shorter. Second one, you can say smaller ground speed, and here there is no change in the air speed of the aircraft. Is that clear? Please take care. There are two velocities, or you can say speeds. One is ground speed, that's we define vg. Another one is what? Another one is nothing but you can say air speed. Then again, for tailwind, longer takeoff distance required, greater ground speed and same air speed. This is for what? This is for the tailwind conditions. Is that clear? If suppose during the time of takeoff, if suppose there is a tailwind, then the takeoff distance will automatically increase. The reason is what? You know very well. We have discussed few examples, or you can say numericals in the class, like how this takeoff distance is associated with the, you can say, the ground speed of the aircraft, right? Or what is the effect of the wind on this takeoff and landing distance? So please go through the class notes. Everything else remaining same, the tailwind increases the range of an aircraft. Yes, that's correct. Option D, for a jet aircraft, constant to fly at constant altitude, there exists an altitude where its range is maximum, right? So just go through the previous question. Now, look carefully. This is our range formula, right? Check. So our range here, range of the aircraft, is depends upon what? It depends upon the density. Say yes or no? Am I audible? What is this density here? This density is directly associated with the altitude of the aircraft. So as the altitude increases, then the ambient density decreases. If the ambient density decreases, it means that what? The range is increases. But there is a certain limit, or you can say it depends upon your power plants, like how powerful it is, or whether it is producing the required amount of the thrust at higher altitude or not. So during the design phase itself, we have to decide like what should be the maximum altitude, or you can say absolute ceiling as well as the service ceiling of the aircraft. So we have to take care of this density value also. Okay, so the option D is also correct here. For a jet aircraft, especially it is written, it's a jet aircraft constant to flight at constant altitude, there exists an altitude where its range is maximum. Yes. So it means that what? If suppose if you are flying a jet engine aircraft near to the ground, obviously its range will decrease. Can you relate? Hello?
Yes,
Can
sir.
you relate?
Yes, sir.
By keeping all the parameters same. So here option B, option C, as well as option D is correct. Okay. So this is the explanation, like what is a headwind, then what is a tailwind, and what is the crosswind. Okay. We have drawn these all diagrams during the live lectures. Now, next question. A propeller-driven airplane has gross takeoff weight of 4905. What is given here? You can see gross takeoff weight, W naught is given. Which airplane is this? It's a propeller-driven airplane. Okay. Takeoff weight is given 4905 Newton. Okay. Then the wing area is given here 6.84 meters square. Then assume that the wings are operating at maximum CL raised power 3 by 2 upon CD of 13. What is given here? CL raised power 3 by 2 upon CD max is given here 13. Okay. The propeller efficiency is 0.9. Here propeller efficiency eta P is given 90%. Then and the specific fuel consumption of the engine is 0.76 kilowatt per hour. So what is given here? You can write C is given here 0.76 kg per kilowatt hour. Okay. Then given that the density of the air at sea level is 1.225. So density at sea level is also given 1.225 kg per meter cube. And the acceleration due to gravity is 9.81. So G is given here 9.81. Okay. The weight of the fuel required. They are seeing, they are asking like what is the weight of fuel required for endurance of 18 hours. So endurance here given 18 hours under sea level conditions in Newtons they are asking. Yes, how to approach this question? You know, most of the time I have seen
By
means
applying.
during the semester exam, right, as well as end semester exam, or when I used to means check the means answers, means copies of, you can say that universities I've seen. Most of the students generally make the mistake at this particular point only. They generally take this values in kgs only because they are used to of this C value in propulsion, right? Am I audible or not? So here, while you are using this formula, endurance formula, please make sure all the units should be in SI units only. Is that clear? Am I audible?
Yes, sir.
Okay. So what is the endurance formula for your piston prop aircraft? This endurance formula E equal to eta P upon C, okay, into then what is the next term? Eta P upon C into
Under
CL raised to power 3 by 2 upon
yes.
CD, right?
Yes, sir.
Into what is the next term?
Root 2 rho infinity into S.
Root 2
Rho infinity S. Yes.
into how much? 1 upon
1 upon root W minus 1 upon root W naught.
right? That's a formula. Now, even if we look at the endurance of this aircraft, right? So the endurance of the aircraft, particularly for this propeller-driven airplane, this E is proportional to what? Proportional to rho infinity, right? Check. It means that what? If suppose if you are flying if the pilot is flying this propeller-driven aircraft means near to the ground, then definitely its endurance will increase, right? Then, if suppose if you want to maximize the endurance of this propeller-based aircraft, then we have to fly this aircraft under minimum power condition. Under minimum power condition, right? Check please. Then obviously, if the propeller efficiency is high, then the endurance will also increases. Okay. Now again, this E is something like this. It means that what? If the value of C is decreases, then the endurance is also increases. But the question is that how to approach this one? Anyone? How to approach? First of all, convert this C value into Newton per watt seconds. Please convert it and let me know how much you're getting. Yes, anyone?
Sir, it is coming 2.071 into 10 to the power minus 6.
How much? Come again.
071 into 10 to the power minus 6.
10 to the power minus
6.
Okay. So let's convert first. C equal to, it is given C equal to 0.76 kg per kilowatt hour. Convert in SI units. So if you want to convert into the Newton, then we have to multiply by G. 0.76 into 9.81 divided by, in 1 kilowatt, how many watts are there? 1000 watts, right? So you can write here, this is 1000. In 1 hour, how many seconds are there? 60 minutes. Then
30
in
seconds.
in 1 minute, there is 60 seconds. So you can write here, it's a 3600, or simply you can write 60 minutes, and then minutes you can convert into second. If you simplify it, or let me write here the units, Newton divided by how much? Watt second. That's it. So if you simplify it further, how much you're getting? 2.071.
2.071 into 10 to power minus 6.
Newton per watt second. Okay. Now, E here is given how much? 18 hours, right? 18 hours. So you can convert into the seconds. So you can write it's 18 into 3600. That's it. Now just apply the formula E equal to eta P, that's a propeller efficiency, divided by CT into root of twice of rho into S into CL raised power 3/2 upon CD into how much? 1 upon root of W1, right? Minus 1 upon root of W0. Please verify this value. Hello, this last term, can you verify? Is it correct or not? Is it correct? Yes. Hello.
There 1 by root W minus 1 by root W0.
So this is correct now. That's what I'm asking.
Yes, sir.
Okay. Now what I'm doing here, since you need what is the weight of the fuel. So please remember this W0 is nothing but you can say W1 plus WF, or simply you can write this W0 is nothing but you can say WE plus WF. Just go through the derivation part. We have taken this W1 is nothing but you can say WE, right? Which is nothing but you can say weight of the, generally student get confused at this particular point, like why you are taking it's an empty weight. Yeah, empty weight is quite different because your overall weight, this W0 is weight of you can say WE, then weight of the fuel, then payload weight is also there, then weight of the you can see cruise is there. So many weights generally we have to consider, right? So for simplicity, I'm considering this W1 is nothing but you can say WE, no issue at all. Or if you want to keep this W1, no issue at all. Okay. Now, so what I'm considering this bracket as a capital X. Let's consider this is nothing but you can say capital X, because if you look at this left hand side and right hand side, right, we have to know like what is the weight of fuel in this case. So CL raised to 3/2 upon CD is known to us, rho value as well as capital S is known to us, propulsive efficiency CT as well as E is given, right? So if you are going to calculate, like if you are putting all these values here, it's quite difficult. So consider this X and calculate the value of capital X is nothing but you can say, what is the E here? You can write it 18 into 3600. Now, what is the value of C here? The C is nothing but you can say, that's not CT. It's a C, I'm considering. It is 2.071 into 10 raised power minus 6 divided by how much? Yes, root of 2. Density is how much? Can you tell me? Density and this
1.225.
1.225. What is capital S here?
6.84.
Are you sure? 6.84? Yeah, 6.84 it is given. Now, just simplify it and let me know how much you're getting. Yes, how much we are getting? Anyone? Yes, how much you're getting? Simran, are you there? Khushi, Mitali?
So it is coming 0.032784.
Wrong. Yes. Narshima, Nandini, Mitali, Khushi, Manvav, Ishika, Janvi. How much you're getting? Ria? Yes, how much you're getting?
Two 2.527 into 10 raised to minus 3. 2.5272 into 10 raised to minus 3.
Okay, any other person?
Sir, 0.03276. 0.03276.
Wrong. Yes. We're having exam in next week, right? And still you are doing this calculation mistake. Very good. Keep it up.
So
Yes.
0.0327826.
How much? 0. Okay, tell me in 10 to the power minus 3 or 10 to the power minus 5, whatever. Okay, let me check myself. This is my calculator. Simran, how much you are getting? Calculator.
Sir, उधर NP value
Yeah, eta p value is also there, right?
CL 342 upon CD value.
Yes, you are right. So generally we have to take this eta p also, right? So what is this eta p? It is given 90%, right? And CL raised power 3/2 upon CD is also given how much?
13.
Yeah, now we'll get the correct one. Yes, how much you're getting?
2.80 into 10
that's
raised to
correct.
minus
2.8019
8019.
into 10 to the power minus 3.
Yes, sir.
Okay. Now, so let me write here. You can write it's a 0.0028. Shall we write? That's a value of x. Now, what is capital X? What you have taken? This capital X. This capital X is nothing but we have taken 1 upon root of W1, right? Check, minus 1 upon root of W0. Say yes or no. So this X value is how much? 0.0028. Now, the overall weight of this aircraft is given or not? The overall weight of this aircraft is given or not? I think it's given. How much it is? It's a 4905, right? So you can write it's a 1 upon root of 4905. Now, just simplify and let me know how much you're getting. Yes, I can see. Just wait. Yes. What is this value? Can you tell me how much you're getting this one? Yes, anyone?
Sir, W1 3460.20.
4905 root of this value. How much? How much this value? How much we're getting? How much you're getting?
0.0142.
0.014228, right? Are you
Yes,
getting?
sir.
So you can write it's a 0.0028 is equal to 1 upon root of W1 minus 0. How much? 0.014228,
0.01427.
right? That's what
Yes.
I'm getting. Now from here, what you can write? The 1 upon root W1 is equal to how much? Tell me. 0.01428 plus 0.0028. So 0.0028 plus 0.01428 is how much? We are getting the 1 upon root W1 is equal to 0.01708. Are you getting this value? Check please.
Yes, sir.
Now from here, what I can write? I can write root W1 is equal to how much? 1 upon 0.01708. So 1 upon answer. Are you getting it's a 58 point something? 58.5.
Yes, sir. 58.553.
Right. So that's a value of root of W1, right? So what you can, if you want to calculate the value of W1, what you have to do?
Squaring.
Squaring,
Yeah,
sir.
Yeah. So I've given this problem as a homework. I think last semester, and some of these students, you know what they did? They have taken the square root of this particular value again to calculate the value of W1. So please don't do that. So just square on both the sides. What you will get? W1 is equal to this square of this one is how much? 3427. Are you getting?
Yes, sir.
3427.86940, right? Newton. So that's a value of W1. Now, what is the W naught? This W naught is nothing but you can say weight of the fuel plus this W1 here. Now, WF is nothing but you can say W naught minus W1. So W1 is giving here 4905 minus what is the value of W1? It's a 3427.8694.
1477.1306.
1477, right?
Yes, sir.
1477.136 something up to 3 decimal point. Otherwise, 130599 you are getting, right? If I'm not wrong.
Yes,
So
sir.
if you write up to the 3 decimal points, or yeah, up to 3 decimal point, we can write WF is equal to how much? 130599. 0.06 Newton. Up to 4 decimal point, up to 3 decimal point, you can write WF is equal to 13. Just a minute.
So 1477.
Just a minute. WF is 1477. Actually, some reflection is coming from there, so it's unable to look at this corner. 1477.1306, right? Up to 4 decimal point, up to 3 decimal point, you can write it's a 1477.131 Newton. Right? Check. So what they are asking, nearest integer or up to 2 decimal point or 3 decimal point, what they are asking?
Sir, nearest integer.
Are you sure? That's right. Yeah, they are saying round off to the nearest integer. So what is the nearest integer here? You can write the nearest integer WF is nothing but you can say 1477 Newton. That's your final answer. Let's check whether this is within the range or not. We are getting 1477, right? 1477. Check. Here range is given 14402 to 1490, right? Means our calculation is correct. Now again, let's look at this particular problem once again. The pitch angle and angle of attack for a fixed wing aircraft are equal during. Is it visible to you, this particular diagram? Is it visible to you? Please let me know first.
Yes, sir.
If not, let me zoom it. Now visible? So look here.
Yes, sir.
During the cruise flight or you can say steady state and level flight only, your pitch angle is exactly equal to, you can see the angle of attack. Okay. So the correct option here is what? Out of the given options, option A. Wings level, constant altitude flight, unaccelerated flight climb? No. What it means by unaccelerated? Means that's nothing what you can say, it's a steady climb, right? Please take care. What we call, it's a steady climb, means the forward speed remains constant, or you can say acceleration is equal to 0. It's very simple. If b is equal to constant, right, then what is the value of dv upon dt? And this dv upon dt is nothing but you can say acceleration. So this value is 0. Why? Because if you are differentiating any constant, let's say this is c. So what is the differentiation of any constant? It's a 0 only, right? So a is equal to 0. It means that it's a unaccelerated flight, or you can say unaccelerated climb is nothing what you can say steady climb. Again, it's an unaccelerated descent. What do you mean by descent? You can say it's a gliding, right? Check. So here what happened? Here rate of climb becomes negative only, right? ROC, or you can say the vertical speed becomes negative. And during the climbing, what happens? Your vertical speed is positive. That's the only difference. So this is also wrong, and obviously during the landing. So the option A is correct. Now, again, they have asked the same question they have asked in GATE 2013. Which one of the following favorable for airplane operation? So first, tailwind in cruise and headwind in landing. So please remember, like what? During the time of takeoff and landing, where takeoff and landing, this headwind is favorable, right? But during the time of cruise or you can say steady state in level flight, your tailwind is favorable. Okay, so just find out which option is correct. First option, tailwind in cruise. Second, headwind in landing. Option is correct. Option B here, tailwind both in cruise and landing. No, not at all. Headwind both in cruise and landing. No. Headwind in cruise and tailwind in landing. No. So if you want to write down something, you can write here one statement like what? Headwind is favorable during what? Takeoff and landing. While during the steady level flight or cruise flight, your tailwind is favorable. or it's a desired? So option A is correct here, right? Check. Now, if an aircraft takes off with 10% less fuel in comparison to its standard configuration, its range is lower by exactly 10%, lower by more than 10%, lower by less than 10%, an unpredictable quantity. Yes, how to approach this question? Really, this question is very, very, very standard. You know, another problem with this question is that they are saying an aircraft, but they haven't mentioned. Hello, am I audible? They haven't mentioned whether it's a propeller-based aircraft or whether it's a jet engine aircraft. Do you know? Hello, check. Am I
Yes,
audible
sir.
or not? They haven't mentioned like which kind of aircraft is this, and they are talking about here the range of this particular aircraft. So how to approach this one? So what is the range formula? What is the range formula for piston engine aircraft? First, can you tell me for piston engine aircraft? Just wait. For piston engine aircraft, and then for jet engine aircraft. Yes, what's the formula? Yes, please. Please keep revising as much as you can. Otherwise, you will struggle during those 3 hours. Remembering the formula is also
So
equal
neta prop by C into CL by CD, ln W naught by W1.
Okay, come again. What you said? For
Sir,
hmm?
the neta prop by C, CL by CD into ln W naught by W1.
For what? For a piston, or you can say for a propeller-based aircraft. But what is the range formula for this jet engine aircraft? Yes. So you are referring your notes. Very good. Keep it up. क्या उम्मीद
No,
रखूं
sir.
मैं आप लोगों को? और क्या है? नो सर क्या होता है? कि नो सर? What is the range formula? Yes. बस मैं चेक कर रहा हूँ कि तुम लोग कर क्या रहे हो वहां पे बैठ के. ठीक है? Yes. What is the range formula?
2 by
Very good.
2 by CD, CL power is 0.5 by CD, under root 2 by rho infinity S, W naught raised to 1 by 2 minus W1 raised to 1 by 2.
Another one?
Which
Another
endurance?
formula? I'm talking here about the range of a piston as well as the jet engine aircraft.
अभी जो मैंने बोला वो जेट का था, अब पिस्टन इंजन का नीटा बाय सी, CL by CD, ln W naught by W1.
CL raised power, what is that? CL upon CD? What is that?
Yes, CL upon CD. Sorry, yes sir, CL upon CD only.
Okay, good. Okay, write down. For piston engine aircraft, you can write R is equal to eta by C. Write down R is equal to eta by C in CL upon CD. ln of how much? ln of
W naught upon W1.
W1. And what is the range formula for jet engine aircraft? Capital R is equal to 2 upon CT.
2 by CT.
2
by
upon
CT.
4 into S into how much? CL raised power?
CL power 0.5 by CD.
1 by 2 upon CD in bracket root of W naught minus root of W1. Is that clear? Check. So just write down R is equal to eta by C for piston engine aircraft. R is equal to eta by P by C into how much? CL upon CD
CL
or L
by
by
CD.
W into ln of W naught upon W1. Okay, then R is equal to how much here? It's a 2 upon CT. Check into root of 2 upon rho infinity into S into CL raised power 1 by 2 upon CD into how much? Yes, please. Root of
Under root W
2
naught minus
minus
under
root
root
of
W1.
W1, right? So now we are just only talking about like in terms of the fuel weight. So if you keep all the parameters same, right? So from these two conditions, we can write R is directly proportional to ln of W0 upon W1 for piston engine aircraft. And here R is proportional to root of W0 minus root of W1. Check please. Now, what is this W1? Look, this W0 is made up of, we can say WF plus W1. This W1 is nothing but you can say, we are considering say WE. This is the weight of the aircraft except weight of the fuel. So let's consider, I'm writing here W0 is equal to WE plus WF. That's what I'm considering at this particular point. So here you can take, this is WE and this is also WE. So first we have to discuss with jet engine or piston engine. Let me know first. Which one you want to discuss here? Jet engine aircraft first? Jet engine aircraft. Okay. So right now for jet engine aircraft. For jet engine aircraft. R is proportional to root of W0 minus root of WE. Right? Check please. Are you agree?
Yes,
okay.
sir.
Let's say W0 and WE is the actual configuration. Actual, or you can say the standard configuration. Corresponds to standard configuration. Let's say. Now, what they say, if suppose it takes up with 10% less fuel, if take off with 10% less fuel, then what happens? Is there any change in WE? Hello? If suppose if this aircraft carries 10% less amount of the fuel, then is there any change in this WE? Which weight will increase or decrease, or you can say which is the function of this WF here? Obviously W0 only, right? Hello, am I audible? Check.
Yes, sir.
So here, whether it is carrying 10% more amount of the fuel or it is carrying 10% less amount of the fuel, the value of WE is not going to change, right? Am I audible? Are you getting this one or not? So just discuss. So let's consider, okay, in this case, consider this is nothing but you can say R prime here. Okay, the range in this case, I'm considering, let's consider this R becomes R prime, W0 becomes W0 prime in this case, and your WE is not going to change. Okay, so let's write here this R prime is proportional to how much? Root of W0. Check. So I'm writing here it's a W0 prime minus root of WE. Check. Here goes. Let's say this is nothing but you can say equation number 1, and this is nothing but you can say equation number 2. Or if you want to simplify it further, right? What we can take? Okay, no issue at all. Take the ratios of these two. Take here. Let's divide equation 2 by equation 1. Then what you can write? You can write R prime upon R equal to how much? Yes, how much will get? Root of W0 prime minus root of WE. Check please. Divided by how much? Root of W0 minus root of WE. Are you agree? Check please.
Yes, sir.
Okay. Now what you can do? Anyone?
Taking
What we can?
taking under root WE common. From numerator and denominator.
What you can do here?
Under
Just
the-
remember, W naught is nothing what you can say WE plus WF, right? Similarly, what you can write? W naught prime is equal to how much? WE
WE
right?
plus WF.
Plus 10% less amount of the fuel. So please take care. Then you can write W naught prime is equal to WE plus 0.9 times of WF. Just put here and simplify. You will take, or you can simplify it further in terms of what you know. WE upon WF, or you can say WF upon WE. Consider that WF upon WE or WE upon WF as a X and take the two limits. When this X tends to 0, then what happens? And then second is what? When this X tends to 1. Okay, so you can take both the hypothetical conditions. You can take, let's say this X is equal to X tends to 0. So first consider X is equal to 0.1, then consider X is equal to 0.2, 0.4, 0.5, 0.6, and let's say up to 0.9 or 0.99. Even you can consider X is equal to 1 and calculate like what is the range here, whether it is decreasing or increasing, means beyond 10% or not. So just calculate. Take your time. Okay, let's define once again. So this W naught prime is equal to how much here? You can write it's a WE plus 10% less amount of the fuel. So you can write here 0.9 WF, right? What is your W naught? It's the actual condition, WE plus WF, right? Check. Put here and simplify. R prime upon R is equal to root of, what is W naught? It's a WE plus 0.9 times of WF minus root of WE divided by root of W naught minus root of WE. Check. Now, what we can do, since this WE value is not going to change, right? Whether it is carrying the same amount of the fuel, less amount of the fuel, or you can say more amount of the fuel. So you can take this WE common here. Okay? Am I audible or not? So we can take this WE common in this, and then we can take this root of WE common in this numerator. Similarly, we can or we can follow the same approach. You can take root of WE common in denominator and just simplify. So let me write here root of WE. If you are taking the common in the numerator, then how much you will get? You'll get root of, let me write first, 1 plus 0.9 times of how much? WF upon WE. Please verify.
Yes, sir.
Minus how much? Minus 1. Agree? Divided by, take here root of WE common in denominator as well. So how much will get? Root of how much? W naught. What is W naught? What is W naught?
WE plus WF.
WE plus WF.
This W naught is nothing but WE plus WF, right? So if suppose if you are writing this W naught upon WE, so this is equivalent to what? 1 plus WF upon WE. Please verify. Agree? Check.
Yes, sir.
Hello. So shall I write here directly? I can write here it's a 1 plus WF upon WE plus how much? Plus 1 here. Plus 1 or minus 1? Sorry, it's minus 1. Minus 1. Clear? Okay. So this root WE and root WE is get cancelled. Now, what we can assume, let's consider this WF upon WE, it's a fraction, right? Weight of fuel divided by, you can say empty weight, or you can say your means the weight of the aircraft. It's the overall weight of the aircraft without, or you can say excluding the weight of the fuel. That's it. Okay. So here, let's consider this is nothing but you can say capital X here. Okay. So what I can write, if suppose if I want to write here further, I can write here is R prime upon capital R equal to how much you are getting? You can write it's a root of 1 plus 0.9x Agree? Check.
Yes, sir.
Minus, what is the value of root 1? It's a 1 only, that's why I have written directly 1 here. Okay, divided by how much? Root of 1 plus x, right? Check please. Minus 1. Hello, am I audible or not? That's
Yes, sir.
this is nothing what you can say. Question number 3. Okay, just help me. Do you want these PPTs? If you want, I can share with you. Hello.
Okay, sir.
So here you can write. Here you can write this. Tell me how much you're getting. R prime upon R equal to. Yes, please. How much you're getting?
Sir, root
Under root 1 plus
1 plus
0.
0.9x, right?
Yes, sir.
Root of 1 plus 0.9x, right?
Minus 1.
Minus 1. That's in numerator. Divided by how much?
Root of 1 plus x
1 plus x
minus 1.
1. That's what we have taken inside question number 3. Now, what is required? They're asking what is the percentage change, right? What asking? They're asking what is the percentage change? How to calculate the percentage change? Yes. So you can write the percentage change is how much here? Percentage change in range. You can write it's a final value, that's R prime minus initial value divided by
Upon R.
initial value, right? Into 100%. Check please. Okay, check. So what is this bracket value? You can write simply, if you further simplify it, it's a R prime upon R minus 1. Check. Agree or not? It's a 7th class mathematics only. Hello.
Yes, sir.
So what you are having? You are having this R prime upon capital R, right? Just calculate what is this R prime upon R minus 1. Okay, and then calculate what is the percentage change. So just wait. Okay, let me write here. This R prime upon R minus 1 is equal to how much? You can write it's a root of 1 plus 0.9x, right? Please correct me if I'm wrong. Divided by root of 1 plus x minus 1 and then minus 1 here, right? Check. Clear? Now just
Yes, sir.
simplify it further. Take this LCM as a root of 1 plus x minus 1 here. So we can write here, this is nothing but you can say root of 1 plus 0.9x, okay, minus 1, then minus how much? In bracket you can write root of 1 plus x, agree? Check. Minus 1. Divided by how much? Root of 1 plus x minus 1. So if you simplify it further, what we can write those? Now we can write this value is equal to, look, if you take, if you open this bracket, what happens? This minus becomes plus only, minus 1 becomes plus 1 only. So this 1 and this 1 is get cancelled. So ultimately how much will get? Root of 1 plus 0.9x, right? Check. Hello, are you getting this? Minus how much? Minus root of 1 plus
x.
Agree? Divided by how much? Root of 1 plus x minus how much? Minus 1. That's it. That's our final value of R prime upon R minus 1. Now here, what is the range of this x? We can take this x tends to 0. One of the, you can say the extreme conditions. Mathematics पढ़ा है नहीं पढ़ा? X tends to 1. This is another, you can say the extreme conditions. Maxima, minima. Hello?
Yes.
थोड़ा बहुत तो mathematics आता होगा. If you are weak in mathematics, it's very difficult to survive in engineering. Okay? Now, take, if you are saying it's a x tends to 0, it is not exactly equal to 0. You can say it's a nearby 0 only, right? So let's consider one value is x is equal to, let's say 0.1. Then you may consider x is equal to 0.5. And in extreme means near to 1, you can consider, let's say it's a x is equal to 0.9. Even if you put x is equal to 1, let's see how much you will get. But it fails exactly at if you are putting x is equal to 0. Will you get anything? You will get it's a 0 by 0, right? Which form is this 0 by 0? What we call? Mathematics पढ़ा है?
L hospital rules.
What is this 0 by 0? What we call? Which form is this?
L hospital rules sir use करते.
Indeterminate form.
But उसको बोलते क्या है? Yeah, very good. That's a 0 by 0 form, right? So if you are putting exactly x is equal to 0 here, how much will get? Root of 1. Here also, it's a root of 1. So 1 minus 1 becomes 0. Here, 1 plus x, right? So how much will get? No, you will get 0, right? You are not getting here. No, you will get 0 only, right? 0 by 0. So if you are putting x is equal to 0 here, what you can write? This r prime upon r minus 1 is equal to how much we are getting? Tell me. 0 by 0. What
Yes,
do you
sir.
mean by x is equal to 0? What is the meaning of 0 here? Look, what is x here? You have taken this x is nothing but you can see weight of fuel divided by how much? WE. Hello, just try to relate it. You are an aeronautical or aerospace engineer, right? So if suppose this is the, you can say this x can be 0 if suppose the weight of the fuel carried by this aircraft is 0, right? Or if suppose the value of WE is how much? Infinity. Am I audible or not? So these are the hypothetical situations. Is that clear? Can you fly aircraft if suppose it is not carrying the fuel? Don't say sir it's electric or you can say solar kind of it, okay, or RC plane. Am I audible or not? So this situation is not possible. This is not possible. But let's say, can we have some value if you are putting near to this 0? Let's say 0.1. Okay, consider case 1. So you can see this is the hypothetical case. Case 2 here. If suppose this x is equal to 0.1, then can you tell me what's the value of this r prime upon r minus 1? How much you are getting? Yes, anyone? Put here x is equal to 0.1. So it is how much? Root of 1.09. Let me check. Where is the calculator?
Yes, sir.
So you will get root of 1.09, right? Minus, if you are putting x is equal to 0.1, so what you will get? Root of 1.1. 1 plus 0.1 is how much? 1.1 only. So minus root of 1.1 divided by root of 1 plus x. What is the root of 1 plus x here? X you are considering it's the 0.1. Sorry, it's a yeah 0.1. So how much will get? Root of 1.1 and then minus 1 here. So root of 1.1 minus 1. How much you are getting? Are you getting around minus 0.0978 something? Please verify.
So minus 0.0987.
I'm getting 0.0978 something, or please verify. Okay, take your time.
Minus 0.0833.
कैसे?
So it is coming minus 0.097896.
Come again, 0.0.
097896.
I'm getting very near value which you are saying. Yes,
Okay.
any other student? Tell me up to the 4 decimal places, at least up to 4 decimal places. मैं ऐसा करता हूँ, डीन सर से कल मीटिंग करने के लिए आता हूँ और बोलता हूँ कि बच्चों को ना एक प्रोफेसर हायर करते हैं हम लोग और आप लोगों को ना ये क्या बोलते हैं कैलकुलेटर कैसे चलाते हैं ना उसके लिए मैं बात करता हूँ. हाँ, फाइनल ईयर पास आउट और थर्ड ईयर वाले स्टूडेंट्स बैठे हुए हैं, कैलकुलेटर चलाना नहीं आता है? यस, हाउ मच यू आर गेटिंग? या एचओडी सर से बात करते हो, अब अभी मैसेज करूं क्या एचओडी को? यस, हाउ मच यू आर गेटिंग? ओ माय गॉड, रियली? एग्जाम किसने लिखना है, मुझे या आपने? ऐसे ही आते हैं वहां पे उन 3 आवर्स में मार्क्स? कॉन्सेप्ट आते हुए भी ना, ये जो तुम ओवर कॉन्फिडेंस में घूम रहे हो ना, रोगे तुम लोग फिर मार्च में। यस यस, हेलो, हाउ मच यू आर गेटिंग? हेलो, एम आई ऑडिबल? Joseph Mansoori, are you there? How much you're getting? Ishika Shavan, Khushi Manbao, Khushi Moda, Khushi, Mitali, are you there? Nandini, Narsimha, Parshav, Pavan, Raju Sankla, Riya, Vedant. How much you're getting? Am I audible to you or not? First, let me know. Hello, am I audible? या फिर आप लोग knowingly आंसर नहीं कर रहे हो, क्या बात है? हेलो, am I audible?
Yes, sir.
तो फिर आंसर क्यों नहीं कर रहा है? कि बारात में आया है क्या किसी की भी यहाँ पे? हाँ, आंसर क्या आ रहा है?
सर वो टोटल आंसर कि r डैश बाय r?
Sorry, come again. I'm saying, what is this? Tell me. Hello. क्या 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 पूछा आपने? एक बार फिर से बोलना मुझे. What you are saying?
r prime by r minus 1 और r prime by r only.
What is this? Hello. ये क्या है? R prime of minus 1 है ना? So tell me this value only.
So minus 1.0833.
Really?
So by taking x 0.1.
X is equal to 0.1. If you are taking x is equal to 0.1, then how much you are getting?
Minus 1.0833.
Are you sure?
Yes, sir.
What about other students?
So it is coming minus 0.097896.
Yes. Any other student? राम पार्षव, क्या कर रहे हो तुम लोग उधर बैठ के? हेलो, माही, आर यू देयर? जीत, आर यू देयर? Okay, let me solve. So if you're putting x is equal to 0.1, please verify. How much will get? Root of 1 point, how much? 0.9 into 0.1, how much will get? 1.09. Check please. Hello, minus root of how much? 1.1. Please verify. If I'm wrong, please let me know first.
Yes,
root
sir.
of 1.1 minus 1. ये कैलकुलेशन
Yes,
नहीं
sir.
है? हाँ, क्या करोगे तुम लोग?
सर यही वाला minus 0.0833 आ रहा है.
0 point minus 0
Minus
point.
0.0833.
Please verify.
Sir, minus 0.09789.
Yes, sir.
यस सर, यही आ रहा है.
Minus
तो
0.09789.
तो आप लोग इतना कैलकुलेशन मिस्टेक क्यों कर रहे हो इसमें? क्यों भाई? Okay, I'm getting this value x is equal to x is equal to minus 0.08732. Are you getting? Sorry, 0.0978 I'm getting. Are you getting this one or not?
Yes, sir.
So if you take this in percentage, then how much you will get? Minus 9.78%. Are you getting this value? Please verify. We put x is equal to 0.1 here. Are you getting?
Yes, sir.
Okay. Suppose take another value. Let's consider x is equal to 0.9 hypothetically. Okay. Consider other value. X is equal to 0.9. Just wait. Okay. Consider x is equal to 0.9 here. Then what is this r prime upon r minus 1? How much we'll get? Root of 1 plus 0.9x, right? So how much we'll get? Root of 1.81 something? 9 9 is 81. So how much will
Yes,
get?
sir.
1.81 minus root of 1 plus x, right? So what do you mean by x here? X is 0.9. So how much it is? 1.9 divided by how much? Root of 1 plus x. So x is equal to 0.9. So root of 1.9 minus 1. Just simplify it and let me know how much you're getting. Please take care of your calculations. At least you are going to lose 5 to 10 marks if you will make calculation the way you are doing in this class. So please take care. Having the knowledge is not enough. Practice karo jitna kar sakte ho. How much you are getting?
So it is coming minus 0.0873204113.
Iska how you are getting minus 0.09715? Huh? Yes. आपका कितना आ रहा है? Second answer
minus
is minus
0.0873204114.
13. Yes, sir.
minus 0.08732
873204
Okay.
040413.
Okay, so if you want to take the percentage, so what you can write? It's r prime upon r minus 1 into 100% only, right? Check. So it becomes how much? Minus 0.08732, right? Into 100%. How much will get? 8.7
8.73.
with negative sign. Meaning what? Even if you take x equal to 1, okay? Another case, it's a case number 3, right? Another case you can consider, let's say x equal to 1 here. Then how much you will get this value r prime upon r minus 1. Root of 1 plus 0.9x. So how much will get? Root of 1. Is that clear? Hello? If you are putting x equal to 1, right? So what is the final form of this equation? Let me check. Root of 1 plus 0.9x, right? So it becomes root of 1.9, check please, minus root of how much? 1 plus x. So x here is 1, so it becomes root 2 divided by how much? Root of, yes please, how much will get? 1 plus x, x is 1, root 2 minus 1. Are you getting any value? Yes, how much will get? Yes, how much you're getting?
So minus 0.086494413.
Come again, what is it? Minus
0.086494413.
minus 0 point, come, yes please,
086
086
49
49
4413.
4413. Okay, so if you want to write up to, you can say the 4 decimal points, so you can write 0.0865. Are you getting this one? Hello, are you getting this one? Please verify this value.
Yes, sir.
865 or 8645? I'm getting this value exactly minus 0 point, how much I'm getting? Minus 0 point
0.8645.
8645, right?
Yes, sir.
क्यों नंदिनी इतना मिस्टेक क्यों हो रहा है आपसे?
सर राउंड ऑफ करने पे ना,
राउंड ऑफ मत करना इसको.
ओके सर.
minus 0.08645. So if you want to write in percentage, then take R prime by R minus 1 into 100%. Again, how much you will get? You will get this value is minus 8.645%, right? So we are getting this range is lower than 10%. What is the meaning of minus here? Hello, what is this? Minus is indicating that's a reduction, or you can say loss in the range, right? Hello,
Yes, sir.
am I audible or not? So it says the range is decreasing, or you can say it is lowered by or reduced by like that only, or it reaches to, or you can say minus 8.645. So please write somewhere minus means loss here, or you can say reduction. So from x is equal to 0.1 to 1, if you are taking this value, we are getting all the values below 10%, right? Check. It means that what? Even if we talk about this jet engine aircraft, which aircraft? Jet engine aircraft, then you can see option C is correct. Which option is correct here? Option C. Let's see what happens if suppose if you are considering the aircraft, means second case is what? Second case you can consider it's a piston engine aircraft. Okay. So in case of this piston engine aircraft, what you can write? Just write down the formula. Here, that's a piston engine. This one, right? Hello.
Above one.
That's for piston engine. So again, from this formula, what you can write? Since all the parameters are remains constant, CL upon CD, eta P upon C, all the parameters if you are keeping constant. Okay, just wait. Something happened. If you are keeping all the parameters same, then we can write R is proportional to how much? ln of W0 upon W1. Say yes or no?
Yes,
Again,
sir.
you may consider here this W1 is nothing but you can say all the weight, or you can say summation of all the weight of the aircraft excluding the fuel weight. Okay. So here you can write W0 is equal to how much? WE plus WF. Please take care of this one. Okay. Let's solve this question. So what you can write? Again, same thing. R is proportional to ln of W0 upon W1. That's your standard configuration. Now, for let's say, if suppose it carries 10% less amount of fuel, same procedure. Let's say then this range of this aircraft, let's say it's R prime. Overall weight of this airplane, let's say it's a W0 prime. And obviously, in this case, this WE prime is nothing what you can say WE only. It is not going to change. Say yes or no first. Hello. And what about
Yes.
the weight of the fuel? Obviously, the weight of the fuel, 10% less amount of the fuel means what? WF prime is nothing but you can say 0.9 times of WF only. That's it. Just apply this condition. We can write, let's say this is nothing but equation number 1. Again, we can write equation number 2. R is proportional to ln of how much? W0 prime, check, divided by W1. Say yes or no. Hello?
Yes, sir.
If you want to write in ratio form, you can, no issue at all. So what is the value W0 upon W1 if you want to write? Or you can take this W0 upon WE right here. What is the W0? It's nothing but you can say WE plus WF divided by WE. Let me simplify it. How much will get? 1 plus WF upon WE. Let's consider this WF upon W is nothing but you can say capital X here. Okay. So simply what you can write here, let's say it's a 1 plus X. But please remember what is this capital X here? Okay. So your equation number 1, finally you can write R is proportional to how much? ln of, tell me how much will you get? ln of how much? 1 plus X only? Check.
1 plus X.
Let's say this is equation number A. Similarly, if you simplify it further, then what you can write here? This W naught prime upon how much? W1 is nothing what you can see. It's a W naught prime upon WE. So what is this value, Prabhuji? Hello, what is this W naught prime? See, this W naught prime is nothing but you can see your empty weight is not going to change. So WE plus how much? How much this value? Obviously, in this case, this WE prime, sorry, WF prime is nothing but how much? 0.9 WF only. So please remember, your W naught prime is nothing but you can say WE plus WF prime only. So this is nothing but you can say WE plus 0.9 times of WF. Clear? Hello? Any doubt? Please let me know. Agree or not?
Yes, sir.
If you simplify it further, what you can write? It's a 1 plus 0.9x. What is x here? X is nothing but you can say WF upon how much? WE, right? Check those. Prabhuji, are you there? Pavan, Narsimha, are you there? So what you can write? R is,
Yes, sir.
take the ratio. Okay, let me write here this R prime, right? R prime is proportional to ln of W naught upon W naught prime upon W1 is nothing but you can say W naught prime upon WE. And what is this value?
1
We are
plus
getting
0.9x.
1 plus 0.9x, right? Let's say this is nothing but equation number B. Now take the ratio equation B by equation A. And what you can write? R prime upon R is equal to how much, Prabhuji? Hello, how much? Ln of 1 plus 0.9x, right? Check. Is it correct
Yes,
or
sir.
not?
Yes, sir.
Are you sure? Please let me know if I'm making any mistake. Please.
Yes, sir.
Are you
That is
sure?
yes, sir.
Ln of 1 plus x. Okay. Let's say if suppose if you want to check like what is the percentage change in R, it's nothing what you can say. Final range minus initial divided by initial into 100%. Right? Check please. Agree, Prabhuji? Are you agree or not?
Yes, sir.
Are you agree or not? Please let me know first. Okay. So again, what you can write? R prime upon R minus 1 into 100%. Clear? Just calculate what is the value of this R prime upon R minus 1. How much will get? You are getting this is nothing ln of 1 plus 0.9x divided by ln of 1 plus x minus how much? Minus 1. Hello? Are you agree or
Yes,
not?
sir.
Simplified further, how much will you get? Ln of 1 plus 0.9x minus ln of 1 plus x divided by ln of 1 plus x. Agree? Check please. Hello? Are you getting this value or not?
Yes, sir. Getting.
Calculate. So that's your final value. Now take x is equal to, again we are having two extreme conditions, but x stands to 0 and x stands to 1, right? Check. Am I audible? Let's consider if suppose this x stands to 0 or consider case 1. Let's say x is equal to 0, then what? Please check whether this one is correct or not. Then what you can write? Then you can write this r prime by r minus 1 is equal to how much? Ln of how much you're getting? X is equal to 0, right? So ln of 1 minus ln of 1, check, divided by how much? Ln of 2? No, ln of 1 only, right? So what is the value of ln of 1? Anyone? Yes? 0, 10,
0.
100, 200, how much? 0?
Yes, sir.
So again, which condition is this? You can say this is not possible. It cannot fly without the fuel, right? Now consider is 2 x tends to, or you can say x is equal to 0.1, then you can write r prime upon r minus 1 is equal to how much? Ln of x is equal to 0.1. So 0.1 into 0.9 is how much? 0.09. Check please. Agree? Minus ln of 1.1. Agree? Hello? Divided by ln of 1.1. Please check this is correct or not.
minus 0.0958.
Minus 0.095818.
Is how much you are getting?
Minus
Minus
0.0958.
Minus 0.0.
0958.
This one?
Yes, sir.
Okay, let me verify. Please verify this value. 0.09
Yes, sir.
minus. Minus 0.09581855 something like that, right?
Yes,
That's what
sir.
you are getting.
Yes, sir.
So this value is nothing but minus 0.09582. Okay. So if suppose if you want to write in percentage, then just multiply by 100. So you will get how much?
Minus 9.58.
Minus 9.582%. So means what? Your range is decreases, right? By what? Minus 9.582%. Let's consider another means hypothetical case. Which case? Hypothetical. X tends to 1. So even if you consider x is equal to 0.9, 0.95, you will get some finite value. Please check, verify. So let's consider. Let's say x is equal to 0.9. Then what you will get? See,
minus
no need
0.07.
to verify these all things. Okay, it is just only for the clarity. Is that clear or not? X is equal to 0.9. So if you are putting this value here, then what you can write r prime upon r minus 1 into 100%. Sorry, is equal to how much? Ln of, look, if you are putting x is equal to 0.9 in this equation, then definitely how much you will get? 0.9 into 9. How much? Ln of 1.81. Please verify. Minus ln of how much? 0.9. So it becomes ln of minus 1.9. Check. Divided by ln of 1.9. Please let me know how much you are getting. Yes.
Sure.
How much you are getting?
Minus 0.075604.
Minus 0.0.
756
Hmm.
04
Okay.
04 Yes, sir.
Okay,
400.
leave it. So please verify this value first. Hello, please verify whether you are getting this one or not.
Yes, sir.
Okay, so just multiply 100, so that's a percentage. So you can write here, this is nothing but you can say when this x is equal to 0.9, then your percentage change is how much?
Minus 7.56.
You are getting this value r prime is equal to how much? How much will get? Yes, please. You are getting this ratio is how much? 7.5604, right?
Yes.
Percent. So again, this is what you can say lower than 10%. So whether it's a jet engine aircraft, or you can say piston based, or you can say whether it's a propeller based aircraft, okay, we are getting these values are lower than 10%. Okay, Kushi, are you getting this one?
Yes, sir.
Now, another question. Question number 8. Now, they are saying a propeller powered aircraft trimmed to attain maximum range. What they are saying? Maximum range. Which aircraft is this? Propeller powered aircraft. Okay, flying in a straight line means in a steady state in level flight, travels a distance capital R, okay, from its takeoff point when it has consumed weight of the fuel equal to 20% of its takeoff weight. Please read this question carefully. If the aircraft continues to fly and consumes a total weight of fuel equal to 50% of its takeoff weight, the distance between, okay, distance between it and its takeoff point becomes. Try to understand this question. So better you can draw the diagram. Okay, let's consider. This is nothing but you can say takeoff point. What is this? Let's consider that's your takeoff point. Okay. Now, let's see. This aircraft is flying in straight line, something like this. Okay. Now, you may consider. Okay. Now try to understand this question. They are saying when this is capital R, when the weight of fuel consumed is how much? 20% of its takeoff weight. So 0.2 times of its W naught. Is that clear? Check please. Now they are saying if suppose the weight of the fuel when the fuel consumed by this aircraft is 50% of its takeoff weight, or you can say initial weight. Let's say at this point, so you may consider this is the point. Okay, let's say this is our aircraft, it is flying. So they are saying at this point when this weight of the fuel consumed is 0.2 times of W naught, then the distance covered by or range covered by this aircraft is capital R. Now let's say this is another point in steady level flight. Let's say when the weight of the fuel is 50% of its takeoff, so you can write when the fuel consumed by the aircraft is 50% of its initial weight of takeoff weight, then they're saying what is this range here? That's what they're asking. Are you getting this one? Hello, Prabhuji. So what is given here? They are saying this range is capital R. So what you can do here? Anyone? It's very straightforward question. Right? Hello? Am I audible or not?
Yes, sir.
So what is the range formula for your jet engine aircraft? Which aircraft is this? It's a propeller powered aircraft. So what is the range formula? Again, capital R is equal to eta P upon C into how much? Yes,
CL by CD.
CL by
Into
CD ln of how much?
W0
W1 upon W1 or W1 upon W0? Please take care. You will be confused in your exam. ठीक है? Exams में यही होता है कि numerator में क्या है और denominator में क्या है. Is that clear or not? Just write down and simplify and tell me how much you are getting. Which option is correct here? I think one more question is there. Then we will stop. Okay. It's the second last question. It's very easy. Look, R is equal to how much? Propeller efficiency divided by C into L by D ratio or CL by CD ratio into how much? Ln of how much? W0 upon W1, right? Check. Clear? So this is a general formula. Okay. Let's say this is our general formula. Okay. Right on case one. What is given? Let's say first case I'm considering. Let's say R1 is equal to R when this weight of fuel is nothing but how much? 0.20% of its initial weight, right? Let's consider case 2. Let's say R2 is equal to, we don't know what is this, when WF is how much? 0.5 times of W0. What we can do? Yes, anyone? Am I audible or not? So from here again, we may consider, see, this is a constant value. Okay. So you can consider, let's say R is proportional to how much? Ln of W0 upon W1. You know very well what is this W0. This W0 is nothing but you can say, let's say it's a W1 plus WF, right? That's it. Simplify. Calculate. So you can write here, let's say R1 is equal to ln of how much, Prabhuji? Yes, please. Ln of, you can write, it's a W01. Sorry. W0 upon W1. Okay. Now R2 is equal to, let's say it's nothing but ln of W0 upon W1, 2. Okay. Or if you want to write this is WE, no issue at all. Okay. So here, what you can write this W11, or let me write here this W0. See, the total weight is not going to change in this case. Okay. In previous case, what happens? The overall weight was changing because the fuel carried by the aircraft were 10% lower than its standard configuration, right? Here, the overall weight is same. Am I audible or not? But during the flight time, obviously, it's a final weight, or you can say its instant weight is keep on changing. Like how? If suppose if you want to calculate, like what is the weight of fuel required, let's say for 2 hours of flight. Okay, for flying hours, then if you know like what is the mass flow rate of the fuel, then you can write the mass flow rate of the fuel into G, into what? Into the time. So that's how you can calculate. Or instantaneous weight you can calculate like W instantaneous. Can you calculate? Anyone? Is how much? Initial weight minus how much? Minus this one only, mass flow rate of the fuel, right? Into G into T. So that's how you can calculate the instantaneous weight of your aircraft. W instantaneous is equal to, let me write once again, W naught minus, so m dot F into G, let me write here, the weight flow rate of the fuel into, you can say, time, instantaneous time. Are you getting this one? So that's how we can calculate. Am I audible? So what is the value of W11 in this case? So you can write here W01 is equal to W02 is equal to W naught. What is your W11? So W11 is given here 20% of W naught. So it's a 0.2 times of W naught. Am I audible to you? Please let me know first. And
Yes,
your W12 is nothing but, you can write it's a 0.5 times of this W naught. Just put these values here. Okay, let's say this is equation number 1 and this is nothing but equation number 2. Okay, check. So take the ratio, let's say equation 2 divided by equation number 1. निकाल दे कितना आएगा यहाँ से? So what you can write? R2 by R1 is equal to how much? ln of W02 by W12 divided by ln of W01 divided by W11. Check please. So what is the value of W02? That's nothing what you can say, initial weight is not going to change. And what is W12? It's nothing what you can say, 0.8 times. Please check, Prabhuji. Devi, are you there? ln of,
यस सर
Devi,
सर वहाँ पे
please,
0.2 लिखना है, वहाँ पे 0.8 आएगा
where?
ऊपर सर W11
Just a minute. What is given here? WF is 0.2 times of W naught. Yeah, you are right. So, okay, let me write here.
W11 yes sir
W11 is how much? You can say
0.8 W
minus how much? Minus how much? 0.
WF
of W naught. So it should be 0.8, right? 0.8
Yes.
W naught. Okay. Then W12 we are getting, it's a 5 here. How we are getting? With the help of this formula only. The instantaneous weight is how much? Initial weight minus weight of fuel, right? That's what we are using here. So again, this W12 we are getting W12 is equal to W naught minus how much? 50%, so 0.5 times of W naught. So you can write W12 is nothing but how much? Prabhuji, 0.5 times of W naught only. Check. W naught divided by W11 is how much? 0. Something is wrong. It should be 0.5 now. No. It's a R2, right? So what is the W02? W01 is equal to W02. Okay, W naught. W11, okay. 0.8 times of W naught. W12, 0.5. Okay. Let me write ln of W naught. Okay. What is W12? 0.5, right? Check.
yes sir
Divided by ln of W01 is how much? W naught only divided by what is the W11? W11 is given 0.8, right? 0.8 times of W naught. So here this W naught get cancelled. Here also to simplify, how much will get? Here you are getting ln of how much? 1 upon 0.5. So are you getting ln of 2?
yes
Check please. Divided by ln 1 upon
1.25
0.8. So 10 by 8. Are you getting 1.25 something?
yes sir
Yeah. ln of 1.25. ln of 1.25. Please calculate and let me know how much you're getting.
3.106
3.10628.
Just a minute. R2 by R1. How much you're getting?
3.10628.
3.10628.
10628.
Right. So what we are considered, what is given here? R1, they are considering it's a capital R, right? And they are asking what is the value of R2. So put here, how much you're getting? R2 is equal to 3.10628 times of what? R1. Say yes or no? Check please. So what is R1 here? You can write R2 is equal to 3.10628 times of capital R. Please take care. You know what is the common mistake generally students do? They don't read the question properly. That's a very disappointing. So they are asking what is the distance from the initial point to the point where the weight of fuel is consumed, like when the fuel, when the total weight of fuel equals to 50% of its takeoff weight, or you can say overall weight of the aircraft. So they are asking this distance. And you know, this option is also given in this question. So which one is correct? 3.1 R. But you know, sometimes students get confused and generally they consider this distance also. So what is this? Let's say it's a R3. So what is the R3? You can say this is the range, or you can say distance covered by the aircraft when the first reading was taken by the pilot. Is that clear? And this is the second reading. Am I audible or not? So at first reading, the distance covered by the aircraft was how much? Capital R. At second reading, when you're considering it's a 50% weight, then you're getting it's a 3 point. You can write here, it's a 3 point. Are we getting correct value or not? How much
Yes,
are
sir.
you getting?
3.1.
3.10628. So if you want to write up to 1 decimal point, let's say if you want to write up to 2 decimal point, then you can write it's a 3.11 R. Up to 1 decimal point, R2 is equal to 3.1 capital R. So let me show you in this diagram. So this R2 you are getting how much? 3.1 times of this capital R, right? So what is this distance?
2.1 R.
So this option is also given in this, right? So R3 is how much? It's a 2.1 capital R. Take care of this one. Okay. So the correct option here is option B, 3.1 R only. That's the last question. To maximize range of jet engine aircraft, it should be flown at a velocity that maximizes first CL by CD ratio, second CL raised power 0.5 upon CD, meaning what? It is nothing but you can say CL raised power 1/2 upon CD only. Okay. Then CL raised power 1.5 upon CD and CL raised power CL square upon CD. Which option is correct here? Which option is correct?
B.
Which aircraft is this? It's a jet engine aircraft, right? Hello. So what is the range formula for this jet engine aircraft? I
2
think it's
upon C under
sorry.
root.
No. Tell me in terms of CL upon CD terms. What's the range formula?
1/2.
CL 1/2.
CL 1/2, right? So here this option E is wrong. It should be option B, right? Check. R is proportional to. Please take care. Please verify whether this is correct or not. So which option is correct here? Option B only. Is that clear? Hello, am I audible or not?
Yes, sir.
Which condition is this? This is nothing but it is the minimum dV by B ratio. Okay.
Yes, sir.
What's the condition? If suppose if we want to calculate what is the range, at what speed is under what condition it should have to means fly. So what's the condition? CD naught equal to CDI,
Well,
1/3 of CDI or 3 times of CDI. Which one?
3 times of CDI.
3 times of CDI, which is nothing but you can say CD naught equal to 3 times of ECL square. Please take care of this one. That's it. And Actually, I'm getting some requests, few requests from the students, like they are very busy tomorrow. They want to revise like few topics, so they want to appear in test on Monday. So I'm going to change the timing of tomorrow's test. Tomorrow's test is postponed to Monday at 9:30 a.m. Okay, please revise tomorrow. Okay, thank you all of
Okay,
you. Good night.